Hey, so today we're going to look at taking samples of a population, and I'll explain that here in a second, and trying to see if we can find bias in those samples. And so, biased and unbiased samples are what we're going to look at today. Um, what a sample is, it is a portion of a population that is intended to represent the entire thing. So, I will explain kind of show what this means. So if we have an entire population, okay, and let's say it's a lot of people or a lot of things, usually it's talking about people, and we can't really ask every single person a question. So maybe it just doesn't make sense. Maybe we're trying to talk about an entire town. We can't ask an entire town of people what they prefer. So instead of asking everyone, what we do is we take out a sample and we ask those people. Okay, and then we use that to help figure out, okay, what is the entire population going to say? A couple of things about the sample that needs to be true. First thing is the sample needs to represent all of the population. So I'll give you an example. We want to see what the school, what Speedway Junior High School thinks about um, what's their favorite subject in school. Okay, and so we want to ask seventh graders and eighth graders. If we just asked seventh graders, that's not going to get a good representation because there's two different grades that go to school here. We want to ask boys and girls. We want to ask students of all different backgrounds because we want to get there's a lot of different backgrounds at the junior high. There's boys and girls at the junior high. There's seventh and eighth graders. And so we want to get a good feel of what everyone thinks is their favorite subject. Uh, if we want to ask people maybe who are athletes, people who are in band, people who are in choir, people who aren't in any type of extracurricular. And so the sample is a small portion, like the picture there, of the entire population, but it needs to represent the entire population. So what happens is sometimes when we take a sample of the population, there could be bias. And so bias is an error. It's not good. We don't want bias. And it's introduced by selecting or encouraging a specific outcome. And there's two different reasons we're going to talk about today why a sample would be biased. An unbiased sample is what we want. Okay, so that's a sample that represents accurately the entire population. So another example would be if we want to see what the town of Speedway thinks about something that's about to happen, and we only ask women, we only ask men, we only ask people who maybe are in one section of town. We don't ask everyone, people in all different areas of the town. Those things are going to present some bias. So thinking about bias, we've got to look at a sample and pick out if there is bias involved in that or if there is not. So a biased sample is one where it's encouraging a specific outcome. Unbiased, remember, that's what we want. So this chart gives us two different examples of an unbiased sample. The first one is called a simple random sample. A simple random sample is you just randomly choose who is going to who's going to be chosen. Okay, so it's completely random. So the example we give, let's go back to the example I started with. We want to ask everyone in Speedway Junior High School what their favorite subject is. So a random way of doing that is to take every student's name, write on a piece of paper, we pick them out randomly. Okay, that's completely random. We're going to get a good depiction of the entire school by choosing those 25 names or whatever we want. The other unbiased sample is a systematic random sample. So notice the key whenever we talk about unbiased samples is the word random. It has to be random. Okay, so I'll write up here random is unbiased. The problem we have is whenever it's not random, that's what's going to provide bias. So random and unbiased go together. A systematic random sample, you have a system that you're using to figure out this sample. So let's go back to what's your favorite subject? Our system could be every 20th person. So we have a list of students alphabetically. Every 20th person, we circled their name. We ask that student what their favorite subject is. Okay, so that's a systematic random sample. So a simple random sample is just like drawing random names out of a hat. Systematic random sample, you have a system. Every 20th student on this list is who we're going to ask. That's our system, and that's still random. So the key to unbiased samples is that it needs to be random. There are a couple of examples of biased samples. So notice that neither of these have anything to do with random. Because they're not random samples, that's going to provide bias into our technique. A convenience sample would be just what's easy. What's the easiest thing to do? So going back to the example that I gave, we want to ask students what their favorite subject is. I just asked the students in my first period class because that's the easiest thing for me to do. Well, that's only seventh graders, only students who were in a math class at that time. Some students might be, drawn to say their favorite subject is math because I'm the one asking the question. And so notice just math class, just seventh graders, that's not going to give a good idea of the entire school, how the entire school feels. So convenience is just doing something because it's easier. Okay, it's going to take a little bit of time to choose every student at random or to go through the list and choose every 20th student. It's convenient for me just to ask my first period. Okay, so that's in one example of a biased sample. The second example of a biased sample is a voluntary response sample. So that's where the only people that are at or that participate are ones who volunteer. This happens a lot. A lot of the samples that you see like on the news or something, usually those are voluntary response. And so there is always bias in those type of samples. But one example would be if I were to send out a survey and I said, if you want to answer this, then do the survey. Not every student's going to answer that survey. And so um, because the only students who answer are ones who chose to, who volunteered to, that's a voluntary response sample. That might not give me a good, accurate depiction. So those are the two type of samples. They're not random. One is convenient, one is voluntary. That means they're not random, which also means they are biased. So what we're going to be doing with our examples is looking at the way that these samples are collected and then figuring out, is it valid? So another way to say this, is it valid? Another way to say that is it unbiased? So we want unbiased. Remember, unbiased means random. And we're going to be using that chart to see, okay, if it's unbiased, it's either systematic or simple random. If it's not unbiased, it would either be convenience or voluntary response. And so this one, a random sample of students at a middle school shows that 10 students prefer listening to rock, 15 hip hop, 25 no music while they exercise. And then the conclusion is that more students, 25, prefer no music. So the question is this valid? Is it unbiased? Is it random? Well, look at a word that you see there, a random sample. So since it is random, we can say that this conclusion is valid because, and the reason why we would give for it being valid is we need to say what type of sample it is. Is there a system that they're using to choose these students? There's no system. So if it's not systematic, it would be a simple random sample. So because it is a simple random sample. So this is valid. It is unbiased. So valid means unbiased because it is a simple random sample. They just randomly choose the students who they're going to survey. Okay, so let's look at our next one. Customers of a music store are surveyed to determine their favorite leisure time activity. That just means what do you like to do in your free time? Okay, and then the store manager concludes that more students prefer listening to music because if you notice, listening to music is what is filled up in most of the chart. Now, the question is, how did they ask these people? Well, the only people who were asked were customers of a music store. Well, if you're asking customers of a music store what they prefer to do in their free time, what are they probably going to say? Probably going to say they prefer listening to music. That's why they're at the music store. And so, is this a random sample? Well, it is not a random sample. So, is the conclusion valid? It is not valid because it is so remember, if it's not valid, that means it's biased. And so we've got those two examples of biased samples. It's either a convenience sample or it is a voluntary response. This one would be a convenience sample because the store manager only asks people who are in his store. That's convenient for him. That's like me asking just my first period class because that's what I'm teaching right now. So it's not valid because this is a convenience sample. He only asked who was convenient to him. Okay, it's a convenient sample, which is not random. So it's not valid because this is a convenience sample, which is not random. If he wanted to make it random, he needed to probably ask people maybe that walked outside of his store and just ask every 10th person. Or maybe ask people in his store and then a sporting goods store and then another store and another store. So ask different groups of people. Okay, so that would not be random, which means there is bias. Okay, so our next one here. Every 10th person that walks into a department store is surveyed to determine their music preference. So out of 150 customers, 70 state they prefer rock. So that's about half of the customers. So this is all good, but the question is it valid? Is this a random sample? Look at how he sampled the people. Every 10th person, so 1, 2, 3, 4, 5, 7, 8, 9, 10, ask that person. 10 people, ask that person. Is that random? Yes, it is. Okay, so this would be valid. Okay, and what type of sample is that? What are they doing? There is a system to it, right? Every 10th person is being questioned. And so it is valid because this is a systematic random sample. This is a systematic. And as long as we add that it is random, that is good enough to prove that it is a valid conclusion or it is unbiased. Okay, as long as we have the word random in there, that tells us that it's not going to be biased. So this is a systematic random sample. So this would be a valid conclusion. All right, so you all go ahead and do this one. Pause the video if you need to. Answer that one. We'll see how we did. Okay, so this one, notice that it is at random, so that is going to be a valid conclusion. We can do that. So the question is not, is this a valid conclusion? The question now is, if 450 pairs of pants are ordered, how many should be jeans? So we can accept that this is a good conclusion. Okay, so what we need to do is figure out what's the total number? Total number of pants. Well, you just add all three of those up. 25 plus 15 plus 10 would be 50. And so 25 out of 50 are jeans. Okay, so jeans would be 25 out of 50, and simplify that. That is 1/2 or 50%, right? Okay, so if half of them are jeans, what we need to do is figure out what is half of 450. So there's a couple ways we could do this. One way you could do this is 25 out of 50 would be what out of 450? Okay, and so 50 times what gives us 450? Well, 50 times 9, which means we need to do 25 times 9. 25 times 9 is going to get us 225. So that's one way we could have answered this. The second way, and that's the answer, 225 out of 450. Second way is we know that 50% of these jeans or of these pants are going to be jeans. And so you could also do 450 times 0.50 because that's 50%. We're trying to find 50% of 450, and that is going to get you 225. Okay, so 225 is our answer. If we have that random sample, as long as it's random, then we can answer a question like this. Okay, so the next one is similar to that. Library is trying to decide what types of books to sell. It surveyed 40 students at random, so this is a valid conclusion. We can answer a question like this because it's random, which means it's not biased. These results are shown in the table. If 200 books are to be sold, how many should be mysteries? So first thing we need to do is figure out how many total books were sold. So add these up. 12 plus 8 is 20. 9 plus 11. Oh, it says it's 40 students. I probably should have read the question there. Okay. And out of 40, 12 are mystery. Okay, so 12 out of 40, which can be simplified. If I divide both by 4, I get 3 out of 10. And 3 out of 10 is also 30%. Okay, so 200 books are to be sold. How many should be mysteries? The two different ways I could answer this, I could say 12 out of 40 equals what out of 200? 40 times what gives us 200? 40 times 5. So I do 12 times 5 and get 60. Or I could also see that it's 30%. The amount of mystery books is 30%. So I do 200 times 0.30. And 200 times 0.30 would give me 60.0. And so 60 would be our answer. Okay, so to wrap up, a random sample could be done by just randomly choosing people or systematically every 10th person, every 20th person we're sampling. That a random sample is unbiased. Unbiased is good. Unbiased means it represents the entire population. That's what we want to happen. Bias is presented when it's a convenience sample, only it's easy for me to ask these people, or if it's a voluntary response, only people that choose to respond are going to be included in this sample. And so you got to look at the samples, see if they're random, see if they're unbiased, and then go from there and say if the conclusion is valid. It's valid if it's unbiased or random. So there are your practice problems. You can get to work on those, and hopefully it makes sense.